Hey, I'm Yakov, and this is the Swift Bird. Earlier today, Apple published Xcode 15, and with it, a new release of Swift, version 5.9. In my previous video, I had a look at what's new in Xcode, and today is all about Swift. Buckle up, because there's a lot to unpack, including something that can really change how you think about memory management. The first notable feature of Swift 5.9 is macros. I already touched on them briefly in my WWDC video, which you can find here. In it, I also cover a couple frameworks that play really nicely with Swift. But because they're separate frameworks, I didn't include them in today's video. On the surface, macros may seem like just reusable pieces of code, not very different from global functions. But in reality, they're much more than that. The critical difference is this. Macros are not part of your app. Instead, they run during compilation and operate on the app's code itself. They can validate expressions such as string literals or replace the code you've written with an expanded version. This reduces the amount of boilerplate because the changes occur on the fly and don't affect your original code base. In my opinion, macros really take to the next level Swift's original promise of making your code safe. It's the Swift way of metaprogramming. Importantly, macros are not just a fancy name for the find and replace feature. They don't treat your code as a body of text, but rather they understand the syntax tree. Swift 5.9 ships two flavors of macros, attached and freestanding. Attached macros look similarly to property wrappers, and roughly speaking they do a similar thing. They attach additional behavior to some symbol without you writing extra code. For example, a macro attached to an async function can generate its completion handler counterpart behind the scenes. The important thing to know is that attached macros require some context in which they work. Also, there's a number of declarations that cannot be generated by a macro. A few examples are import statements, type extensions, and operators. Freestanding macros give up the context available to attached ones, but in return, they provide more opportunities for use. That's because freestanding macros can expand into pretty much any code. They can even substitute parameters dynamically. The example given in the proposal shows how different variants of numeric types can be generated with a single macro. Note that the attributes specified on the macro, such as available here, get transferred to the resultant declarations automatically. The next big addition to Swift is almost invisible. Someone going through a random code file would very likely not notice it, unless they knew what to look for. But I think it's gonna be a very welcome thing. Many versions ago, Swift allowed implicit returns in functions and computed variables. Basically, if there was only one expression, it was treated as the return value. However, if and switch statements did not get the same feature, which introduced some inconsistency in the language. I've seen a dozen different hacks to make such code shorter. Usually though, those hacks just made it less readable. But now, this gap is finally getting filled. In Swift 5.9, you can use either structure as a value to return from a function or assign to a variable. What's more, explicit returns inside the structures are no longer required. This only works if you follow a few rules, but they are pretty simple. Just as with functions, you can have only one expression in each branch. All branches must return some value, and all values must be of the same type. Because of this last principle, if expressions require an else block to work. There's a couple more restrictions for result builders and pattern matching, but since you don't deal with them as often, I'll just post a link below so you can have a look later. And now is the big one. Swift 5.9 lets you explicitly control the lifetime of values. Aside from some caveats, automatic reference counting pretty much eliminates the uncertainty of memory management. To put it simply, it just works. But ARC is not free. Every time you create, use, or pass a value somewhere else, the runtime makes a number of calls to manage the memory. With most hardware, this overhead is completely negligible. But in some performance-sensitive cases, you want to squeeze out every byte and clock cycle. For that, Swift introduces the concept of borrowing and consuming. A borrowed parameter in a function is guaranteed to exist for the entire duration of the call, but the caller can still use it later when the function is finished. A consumed parameter, on the other hand, is taken away from the caller and cannot be reused. Now the function which received it is responsible for doing something, passing it on or releasing. The last part may sound scary, but it's actually pretty simple. When the function returns, everything in the local scope is destroyed, so you don't have to release it manually. Either keyword reduces the number of behind-the-scenes calls to ARC, which can greatly benefit low-performance devices. I'm basically thinking about IoT and things like Raspberry Pi. Explicit ownership is not limited to function calls. You can see the difference with just a few lines in a playground. To me, this whole concept of consuming and borrowing resembles memory management in Rust. Of course, it's not a one-to-one equivalent, but that's just a feeling I can't shake off. Rust is known for having a pretty steep learning curve. Swift, on the other hand, is designed to be safe and friendly, so even though explicit ownership is a big thing, I guess you're not gonna see it very often. In my opinion, Swift 5.9 is one of the most important releases, since at least Swift 4 in 2017. Macros help you make the code smaller and safer. These syntactic improvements add the missing piece of consistency. And the new memory management tools make Swift more appealing for embedded software and low-performance devices. Even though I treat software development as only a tool, this time I can totally understand those who enjoy programming just for the sake of programming. That's it for today's video. But it's only the beginning for the new Swift. Something tells me there's still a lot I can cover on this channel, so subscribe to the Swift Bird. And if you found this video helpful, please give it a like. Stay tuned for more, and with that, make your Swift fly.